Let's start with indices in this video. Before we discuss the laws of indices, let's look at what indices really mean. When we are talking about indices, we are talking about power or exponents. For example, a, if I have a to the power of m, you see this m is called the what? It's called the index. It's called the index. Plural of index is indices. We call it index. Another word for index is exponent. So if I want to say law of indices, I can also say law of exponents. So let's see laws that guide these powers together. Let's see the laws that guide them. So the first law is this. See, if I have a to the power of n multiplying a to the power of n, you see this a is called the base, while this is called the power, index or exponent. Now, take note that whenever you are having the same base and what is between them is a multiplication sign, you can pick one of the base and add the powers together. The second rule, if I have a raised to power m divided by a to the power of n. Now, check it out. If you have the same base, we can pick one. If it is divide, you are going to subtract the power n minus n. Now, take note of something that if I have something like this, a raised to power m plus a raised to power n, you see this, it is never equal to a raised to power m times n. This is not true. You see, before you can apply the law of indices to the same base like this, what you must have between them should either be multiplication sign or division sign. If it is addition sign, it will not work. All right, so let's go on. If I have a raised to power m, I have another bracket with a power again. Note that bracket means multiplication, so I'll multiply the powers together. The fourth rule, any number, a number raised to power 0 is equal to 1. Are you there? Except 0 raised to power 0. 0 raised to power 0 is undefined. But any number other than 0, like 5 raised to power 0, 7 raised to power 0, 1 over 2 raised to power 0, minus 1 over 2 raised to power 0, is equals to what? Equal to 1. Now, the next one, see if I have a negative power. For example, if I'm having a raised to power minus n, you see, to get rid of a negative sign, you are going to say 1 over a raised to power m. What do you observe? Negative sign should change to 1 over, then you write what you have remaining, and that is it. So the next law is this. If I have, let me say I have a raised to power 1 over m. What you're having here is what? 1 over a power. So that power will be like a root, mth root of a. Let me use a number so that we can understand it very well. For example, if I have a raised to power 1 over 2, this 1 over 2, it will become a root. This thing is a root, square root of a. If I have a raised to the power of 1 over 3, this means cube root of a. That's cube root of a. That is, root. Put your 3. But in square, we don't put square, we don't put 2 here, just square root. If I have a raised to power 1 over 4, this means fourth root of a. And that is it. Also, if I'm having the seventh law, if I'm having a to the power of, let me say, n over m. Now, what is here is not 1. We are now having a number n. What will I do? You see, this number at the denominator you are looking at here, it will still become the roots. So I'm still having nth root of a. Nth root of a. And this n will now become the power. You see, the power can be written in two ways. The power can be written in two ways. You can write it here, raised to power n, or you write it like this. Or you write it like this. Either of the way. So you can put the n outside or inside. Either of the way, you are correct. Now, take note of these laws of indices very well. And since you've taken note, let us just look at something that you need to take note of again. You can take it as a law or not. See, if I'm having a fraction, like let me see a over b, I'm now having raised to power m. So take note that this power is talking to both of them. So I can say a raised to the power m, b raised to power m. Very important. Also, if I'm having a raised to the power of m, if I'm having ab raised to the power of m, so this is same thing as a raised to power m times b raised to power what? N. The power will go for both of them. So take note of this. They are very, very important and vital. So since we know this, let us solve question. Let me see if I can move this or make it smaller. Okay, so let me move it somewhere here. Okay, let's solve question. So this is the first question. We have 16 raised to the power of 1 minus 1 over 2 times 4 raised to the power of minus 1 over 2 times 27 to the power of 1 over 3. Now, how do we do this? Don't rush it. The first thing you have to do here is that whenever you see a negative power, quickly apply this law. That is, just say 1 over 16 raised to power half. You see that that minus sign is the one you use to write this 1 over. This minus change to 1 over. So you have 1 over, then 16 raised to power half. Then times what you have here, C minus here. This minus also 1 over 4 raised to power half. Then what you have here does not have minus, so replace it like that. Good. The next step is this. Remember, whenever you have 1 over 2, see, remember what I told you, 1 over n, nth root. So this 1 over 2 means, at the power, means square root of 16. Okay? So times, what I'm having here is 1 over, this means square root of 4. You can see? Then times, this means cube root of 27. We've discussed that earlier. So what I have here is 1 over, what's the square root of 16? That's 4. Times, what's the square root of 4 here? That's 2. What's the cube root of 27? What we multiply 3 times to give 27? That is 3. So you give me what? 1 times 3 times 3 will give me 3. 4 times 2 will give me 8. My answer is 3 over 8. It is very simple. Next question. Next question is this. If I have 8 to the power of 1 over 3 times 5 to the power of 2 over 3 all over 10 to the power of 2 over 3. Now, look at what I'm having here. See, you observe that nothing is having the same base or anything. So what do you think I can do here? Observe. You might be correct if I say, let me find the cube root of 8, because this means cube root of 8. But if you observe, all these don't have cube roots. So what do you think I can do? Okay, see, another way to solve this thing is that, see, remember that 8 is the same thing as 2 raised to power 3. So I can write 8 as, of course, 2 raised to power 3. So I'll just put my half there. My raised to power 1 over 3 there. Times what I'm having here. Just leave it as 2 raised to power 5 raised to power 2 over 3. Because if you take the cube root of 5, it will give you a decimal. So that's why I don't want to take it. So just leave it the way you have it. Then all over. This is just 10 raised to power 2 over 3. But I want to write this 10 as 2 times 5 raised to power 2 over 3. This is what I have. Now, this 3 here, we take care of this 3 here. So you have 2 times, I have 5 raised to power 2 over 3. Then all over. Now look at this. Remember the law I did. This is the law. If you have AB, A times B raised to power m. So it's A raised to power m times B raised to power m. So what I'm having here now will be what? 2 raised to power 2 over 3 times 5 raised to power 2 over 3. So since I have that, then if you observe, so this can cancel this. Then you'll be having 2. If you have ordinary 2, it means 2 raised to power 1 over 2 raised to power 2 over 3. So since we have this, we are going to use this law of indices. Remember, the same base, what I'm having here is like 2 raised to power 1 divided by 2 raised to power 2 over 3. So you pick one of the base, then you minus the power, 1 minus 2 over 3. So 1 minus 2 over 3 is what? That's 1 over 3. So you take the LCM, so that's 1 over 3. And this is my final answer. 1 over 3 at the power still means cube root of 3. Okay, so that's that for that. Next question. Next question. If I have 343 to the power of 1 over 3 times 0.14 negative 1 times 25 negative minus 1 over 2. So what do we do here? Very simple. This means cube root of 343 times negative power 1 over 0.14. And what I'm having here is 1 over 25 raised to power half. Remember, negative sign will make you have 1 over. Negative sign is 1 over. So cube root of 343. What will you multiply 3 times to give you 343? That will give you 7 times 0.14 as a fraction means 14 over 100. Then this means square root of 25. So I have 7 times. This will be equal to what? 100 over 14. So to flip like 100 over 14. Then times this will give me what? 5. So observe that this is 7 year 1, 7 year 2, 2 year 1, 2 year will give me 50. Then 5 year 1, 5 year will give me 10. So my answer is equals to what? 10. Next question. Next question. If I have 27 to the power of minus 2 over 3 times 25 to the power of 1 over 2 times 5 to the power of 0. So whenever you have negative power, we already know to be 1 over 27, so 2 over 3 times this does not have negative power, I'll repeat it. Anything raised to power 0 is 1. So from here, what will I do? You observe that I have 1 all over C. Remember when I'm having a kind of fractional power like this down one will be the root, and this up one, which is 2, will be the power. Then times this already means square root of 25. So I have 1 all over cube root of 27 is 3. Then I have 3 square times this is 5. So 5 over 3 square is 9. 5 over 9. Next question. If I have 25 raised to power minus half times 27 raised to power 1 over 3 plus 121 raised to power minus 1 over 2 times 625 raised to the power of minus 1 over 4. So what do we do here? What you are going to do here is that, observe, you have multiplication and you have addition. According to BODMAS, you have to finish this multiplication, then you add your result together. And at this side, remember, this will give me 1 all over 25 raised to power half, negative power. This is 27 raised to power 1 over 3. So plus this 1 over 121 raised to power half, then times 1 all over 625 raised to power 1 over 4. So negative power has been fulfilled. So after that, remember, what I'm having here is 1 over square root of 25. Raised to power half means square root. Raised to power 1 over 3 means cube root. Plus this means square root of 121 times 1 over this means fourth root of 625. It means that what we multiply 4 times to give you 625, and if you do that, you should get 5. So this is 1 over square root of 25 is 5, cube root of 27 is 3, plus this is 11 times this is 5. So this is 3 over 5 plus this is 1 over 55. You can see. So after you've multiplied out, then you now add your result. So the LCM here is 55. 5 in 55 is 11. 11 times 3 is 33. Plus this and this is 1. 1 times 1 is 1. And that's what 34 over 55. That's that for that. All right. So let's go. Next, if you have 3 root 3 to the power of 2 over 3 plus 27 2 over 3 times 9 minus 1 over 2. This is what we have. So take note, whenever you're having plus, don't ever apply law of indices, because law of indices, like between two entity, you always have multiplication or division. So this is plus. It means that you have to finish this, then add the answers together. So remember that what is inside this bracket, I can write as 3 times what I'm having here. Square root of 3 is 3 raised to power half. Do you remember? Square root of 3 is 3 raised to power half. Then I have my power 2 over 3. Then plus. So I still have 27 2 over 3 times. This is the negative power. That's 1 over 9 raised to power half. All right. Remember this law. Whenever you're having a power, you can separate. So far that what you're having in this bracket is multiplication. You can give the powers to both of them whenever you're having multiplication. But assuming it is addition that you're having, you are not having a power. Don't separate it to only if it is multiplication or division. Please don't forget. All right. So here I'll apply law of indices. Remember, law of multiplication, take a base and add the powers together. So 1 plus half. And what's happening here? Remember, can you pause the video to evaluate this cube roots of 27? Then you square your results. Then just put that on the back. Then times this is square root of 9. So this is 2 plus 1 plus half. That's 1.5. That's 3 over 2. 3 raised to power 3 over 2. Then times 2 over 3. Then plus this is cube root of 27 is 3. 3 squared 9. Yeah, 3 squared 9. Then times 1 over square root of 9 is 3. So you observe, this will multiply like this. Remember this law? It's talking about this law. So you multiply out like 3 over 2 times 2 over 3. Then plus, this one is 3 here, 1, 3 here, 3. And that's 3. So this will give me cancel. That's 3 raised to power 1. And that's 3 plus 3. That's equals to what? 6, not 9, 6. Okay. As you can see, it is very simple. So take it step by step so you get the concept. All right. Okay. All right. So now we've solved the first phase of the question. Now let's see what if you have questions like this. Okay, for me to solve the question now, I'll erase this. So I will assume that you've learned all the laws by heart now. So let's start. If I have 4 2 raised to power n plus 1 minus 2 to the power of n plus 2 all over 2 raised to power n plus 1 minus 2 to the n. So see what I'm having here now. Remember, law of indices, there's none of them that have negative between or positive between. It's only multiplication and division. That's only what you have. But if you're having a minus, what do you think you will do? If you're having a minus, what do you think you will do? Okay? Remember, law of indices always start with, let me say, times or divided by. But if you have multiplication or addition, what will you do? This is what you are going to do. You see, you are going to solve this thing by factorizing. Let's take a look. Remember that if I have a raised to power m times a raised to power n, it's the same thing as a raised to power m plus n. You know, if I say a raised to power m plus n, it means that a raised to power m times a raised to power n. If I just reverse this. So it means that if I'm having 2 raised to power n plus 1 is the same thing as 2 raised to power n times 2 raised to power 1. If I apply law of indices back, I will get this. Minus, this is the same thing as me saying 2 raised to power n times 2 raised to power 2 then all over, this is the same thing as 2 raised to power n times 2 raised to power 1, then minus this is 2 raised to power n. This is what I have. Now, what do I mean by you solve by factorization? If you observe, 2 raised to power n is common to all of them, so you factorize it out. So here I have 4 already. So let me factorize that 2 raised to power n out. So multiply by 2 raised to power n. Then what happens? So I'll put back the remaining ones. So I have 2 raised to power 1 minus, what am I having here? 2 raised to power 2. Remember that I have factorized what is common. Oh, wait. Please hold. Hold, please. So don't get something twisted there. Look at this part. If I factorize 2 raised to power n out, I'll be having this side only. I'll be having 4 and 2 left. And that's 4 times 2. And that is what? 8 left. Do you get that? If I remove 2 raised to power n out, I'll be left with 4 times 2, and that's 8. Minus, if I remove 2 raised to power n here, I'll be left with 2 raised to power 2, and that is 4. Then all over this side, if I remove 2 raised to power n, I'll be having 2 left, 2 raised to power 1 left, minus. Here, if I remove 2 raised to power n here, I'll be having nothing remaining, and what I'm having just 1. Because 1 is like a coefficient of everything. So if you remove 2 raised to power n out, you'll be having 1 remaining. So here is 2 raised to power n times n minus 4 is 8 minus 4 is 4. So I have, you can cancel out this. So this will give me 4 over 1, and my answer is 4. That's very simple. So if you see a question of this kind, this is the pattern you'll be using to solve such questions. You're using this same pattern to solve that same question. Okay, let me give us another one. 3, 5 raised to power n plus 1 plus 5 raised to power n all over 5 raised to power n minus 2 minus 5 raised to power n minus 1. You can pause the video to give the problem a try. So let's see how you can go about it. So I'll be using same pattern. So 3, what I'm having here is 5 raised to power n times 5 raised to power 1 plus 5 raised to power n all over. Here is 5 raised to power n times 5 raised to power minus 2. Then minus, this is 5 raised to power n times 5 raised to power minus 1. So what's common to all of them is 5 raised to power n. Now look at this part. If I remove 5 raised to power n here, I'll be left with 3 times 5, and that's 15. Plus, if I remove 5 raised to power n here, you'll be left with 1 all over. If you remove 5 raised to power n here, you'll be left with 5 raised to power minus 2. And 5 raised to power minus 2 is the same thing as what 5. See, let me remind us. 5 raised to power minus 2 in law of indices is 1 over 5 raised to power 2, and that's 1 over 25. 1 over 25 minus, this is, you'll be left with 5 raised to power minus 1 here, and that's 1 over 5. So if you factorize 5 raised to power n out, this is what you'll be having. So this will cancel this. So when you have this, the next thing is that okay. So the next thing is that you'll be having 15 plus 1, that is 16, all over 1 over 25 minus 1 over 5. So this is what 16 divided by, what you're having here, what's the LCM? LCM is 25. So 1 in 25 is 1, 1 times 1 is 1, minus 5 in 25 is 2, 2 times 1 is 2. So I have 16 divided by minus 1 over 25. So what I'm having here is like 16 divided by minus 1 over 25. And that's 16 times 25 over minus 1. And what would that give me? So if I have 25, 16 times 25, that will give me minus 4. So I have minus 400. So that's that for that. So that's how to solve problems like this. So let me give us a task and put your answer in the comment section for me to know you really know it and you are following. So this is your answer. So this is your task. So solve this and put your answer in the comment section. Evaluate t raised to power n minus t raised to power n minus 1 all over t raised to power 3 times t raised to power n minus 27 times 3 raised to power n minus 1. So put your answer in the comment section. Thanks for watching.